In this lesson, we're going to simplify an expression 3 different ways. And of course, this expression is the sum of 2 algebraic fractions with unlike denominators. But on close examination, we can see that those 2 denominators are opposites of one another. So the best way to do it is to select one of the 2 fractions and multiply that fraction by -1 over itself. And when we do that, we get this. Notice we've used the distributive property with the denominator. We've done the 5 times the -1 to get -5. And where it says subtract n, that's like the opposite of n, and the opposite of n times -1 is n. So one of the denominators now is n minus 5, and the other is -5 plus n. But we know that we can rewrite the second one so that it's also n minus 5, because those 2 expressions were really 2 different ways of writing the same expression. Now we have a common denominator. Our numerators are 6n and -11n, which makes -5n as our numerator. And in fact, that fraction down at the bottom left is an acceptable way to write this expression in simplified form. But there are 2 other ways that could be acceptable. If we factor out a -1 from both the numerator and the denominator, then cancel it out because -1 over itself is 1, we get this expression, which is equivalent to the other, just another way to write it. And if you prefer, you can also write it this way. And in fact, the way on the bottom right probably uses less ink or pencil to write, not by much, but all 3 of these expressions are acceptable ways of writing a simplified expression to replace the original sum of the 2 algebraic fractions at the top of this frame. Well, now let's look at this same problem. We could multiply the other fraction by -1 over itself. It's not going to change things that much, but it will give us a different denominator. Instead of giving us n minus 5 as the denominator, we get 5 minus n as the denominator. And then we combine -6n plus 11n, and we get 5n over 5 minus n, which is a very acceptable way. It's one of the ways we saw before, but again, we can also factor out the -1s and cancel them, so that if we want to write it one of the other 2 acceptable ways, we may. Again, on this particular method, I like the very first answer that I got, which was the one on the bottom left, but if you like the other 2 better, you may use those as well. And then we're going to take one more look at this. Many times students don't notice that these 2 denominators are opposites. They just see these 2 denominators as unlike denominators with no common factors. So they do this. They multiply the first one by 5 minus n over 5 minus n, and then of course multiply the second one by n minus 5 over n minus 5, giving us this, which is a lot more stuff going on than the first 2 methods that we used. But if we're careful, we can still get the right answer. Now, our denominator is an unusual trinomial because we tend to like trinomials where the term that has the square in it, in this case n squared, is just n squared. And of course, in our trinomial, it says the opposite of n squared. So we're going to choose to factor out a -1 for that trinomial. And once we get the -1 out, we see a perfect square trinomial, which we can factor as shown. And then we can cancel some common factors, because the top has an n minus 5. The bottom, of course, has 2 of those factors. We cancel one of them out, and we're left with this. And of course, I hope you remember how fractions work with negative symbols. We have the -1 at the bottom, but since 1 over -1 and -1 over 1 are the same thing, we can move that -1 up to the top and then just multiply it times 5n to get -5n. And then, of course, you can recall that -5n over n minus 5 has 2 other acceptable ways that we've already looked at in the previous 2 methods. So once again, we've looked at a single addition of algebraic fractions problem, worked it out by 3 different methods in this lesson. The first two methods, where we noticed that the denominators were opposites, were very similar. And the final method we looked at was something you could get into if you failed to notice that the denominators were opposites. But if you follow the rules and pay close attention to your arithmetic, you can still get to the correct final result. Adding and subtracting algebraic fractions follows the same rules used for adding and subtracting numerical fractions. Use factoring to rewrite all fractions with a common denominator, then add or subtract the numerators. Use factoring again to express the sum or difference in lowest terms.